Welcome to our channel with interesting episode. However, its calm waters can quickly become dangerous when the water levels rise. The river is expected to crest later this week, and while some areas may not experience much impact, others could face significant challenges. Often called the Big Muddy, the Missouri River is an incredible and complex waterway that has shaped the land and history of the regions it passes through. It is amazing to think that this river, which now flows southward to meet the Mississippi River near St. Louis, Missouri, before emptying into the Gulf of Mexico, once took a completely different course. Long ago, instead of flowing south, it traveled northeast into Canada and eventually reached Hudson Bay. Scientists have studied its ancient pathways and discovered the reasons behind this dramatic shift. Understanding how the river changed direction requires exploring its origins and the forces that shaped its journey over thousands of years. The Missouri River begins its journey at the Continental Divide, specifically in Yellowstone National Park. In this vast and geologically active area, the Firehole River plays a crucial role in the river's early formation. The Firehole River gathers water from geysers, including the famous Old Faithful. Old Faithful is one of the most well-known geysers in the world, regularly erupting and shooting boiling water and steam high into the air. This hot, mineral-rich water joins the Firehole River, which then continues its journey, picking up more water from the Grand Prismatic Spring. The Grand Prismatic Spring is an extraordinary hot spring known for its vivid colors, which result from microbial mats that thrive in the mineral-rich water. As these waters merge, they form the Madison River, a critical artery in the early stages of the Missouri River's development. As the Madison River flows out of Yellowstone National Park, it passes through picturesque valleys and rugged canyons. The river is not just a scenic wonder but also an essential part of the region's ecosystem, providing a habitat for diverse wildlife and a popular destination for fishing enthusiasts. The Madison River eventually converges with the Jefferson and Gallatin Rivers, and together, they form what is known today as the Missouri River. This newly formed river begins carving its path through stunning landscapes, creating valleys, gorges, and canyons as it continues its long journey toward the Great Plains. The Missouri River is not just a waterway, it is a lifeline for the land it touches. As it moves through different terrains, it picks up sediments and minerals, carrying them downstream and depositing them along its banks. These deposits have enriched the soil, making the surrounding lands some of the most fertile regions for agriculture. Farmers have relied on the Missouri River's rich soil for generations, growing crops that support local economies and provide food for communities near and far. The river's journey from the mountains to the plains showcases the dynamic natural processes that shape our world. One of the most surprising discoveries about the Missouri River is its ancient course. Today, the river flows southward, joining the Mississippi River and eventually reaching the Gulf of Mexico. However, long ago, it traveled in the opposite direction, flowing northeast into Canada and all the way to Hudson Bay. This drastic shift in direction raises fascinating questions. How did the river, which once flowed toward the north, change its path so dramatically? What natural forces were at play to redirect such a vast and powerful waterway? These mysteries have intrigued scientists for years, and through careful study of the landscape, sediment deposits, and geological history, they have uncovered clues that reveal the river's astonishing transformation. The key to understanding this change lies in the study of ancient glacial activity. Thousands of years ago, during the Ice Age, massive glacier covered large parts of North America. These glacier shaped the land, carving valleys, shifting river courses, and creating new pathways for water to flow. When the glacier began to retreat, they left behind enormous amounts of meltwater, which needed a path to escape. This meltwater influenced river systems, sometimes redirecting their courses entirely. Scientists believe that the Missouri River was once part of a much larger system that drained into Hudson Bay. However, as the glacier melted and new landforms emerged, the river's course was altered. Over time, shifting sediments, changing elevations, and natural barriers forced the Missouri River to take a new direction, leading it southward to its present course. By examining layers of sediment and ancient riverbeds, geologists have been able to reconstruct the Missouri River's prehistoric roots. Fossilized remains of aquatic life, mineral deposits, and soil compositions provide evidence of water flow patterns from thousands of years ago. These studies confirm that the river once followed a very different path before adopting its current trajectory. The realization that such a massive river could change direction so drastically is a testament to the ever-changing nature of our planet. Rivers are not static, they evolve over time, influenced by geological events, climate changes, and the shifting of the Earth's surface. The Missouri River has continued to shape human history just as it has shaped the land. Indigenous peoples have lived along its banks for thousands of years, relying on its waters for sustenance, transportation, and trade. Later, European explorers and settlers recognized the river's importance, using it as a major route for expansion and commerce. The Lewis and Clark expedition, one of the most significant exploratory missions in American history, used the Missouri River as a primary route to chart the western territories of the United States. Their journey, guided in part by indigenous knowledge, revealed the vastness and richness of the land surrounding the river. Over the years, the Missouri River has remained a vital resource, but it has also presented challenges. Its waters can be unpredictable, and flooding has historically caused devastation to communities along its banks. Efforts to control and manage the river, including the construction of dams and levees, have helped mitigate some of these risks. However, nature often reminds us of its power. Even today, as water levels fluctuate, communities must prepare for the river's impact, whether through flooding or drought conditions. Despite these challenges, the Missouri River continues to be a source of beauty, sustenance, and inspiration. Its winding path through mountains, valleys, and plains tells the story of a river that has endured immense change over millennia. The knowledge gained from studying its history allows us to appreciate not only the river itself but also the dynamic forces that shape our world. The Missouri River's journey, from its beginnings in Yellowstone, through breathtaking landscapes, across fertile plains, and finally to its meeting with the Mississippi, demonstrates the incredible ways in which nature transforms over time. Understanding the history of the Missouri River gives us a deeper appreciation of the forces that have shaped North America's landscape. It is remarkable to think that this river, which today provides water, supports agriculture, and serves as a hub for wildlife, once followed an entirely different path. The mysteries of its past, revealed through geological research, remind us that the Earth is constantly changing, and that even the most powerful rivers are not immune to the passage of time and the forces of nature. Geologists have spent years piecing together the fascinating history of the Missouri River by analyzing geological clues left behind by time and nature. One of the most intriguing discoveries about the river's past comes from studying the abrupt changes in its path. At Coalbank, the Missouri River suddenly shifts direction and begins flowing southward. This unusual turn sparked curiosity among scientists, leading them to investigate further. What they found was extraordinary. The Missouri River once flowed northeast into Canada before dramatically changing course and heading southward. But how did this happen? What forces were at play to redirect such a significant waterway? To uncover the river's ancient pathways, geologists examined various factors, including the terrain, sediment layers, and river terraces. River terraces are particularly valuable in understanding the history of water flow over time. These terraces are remnants of old riverbeds, revealing how rivers have moved, eroded, and deposited material across landscapes. The study of terraces allows geologists to reconstruct how the Missouri River changed its path and adapted to shifting environmental conditions. To gain a broader perspective on river history, geologists often turn to other rivers for comparison. Moving southward to the Yellowstone River, north of Yellowstone National Park, scientists apply geological principles to understand how rivers evolve over time. The Yellowstone River provides a perfect example of river terraces and their significance in studying historical river paths. Standing on the banks of the Yellowstone River in Paradise Valley, one can see how this mighty river has carved its way from the highlands of Wyoming, through Yellowstone Lake, cascading over the breathtaking falls of the Grand Canyon of the Yellowstone, and eventually reaching the Great Plains. Observing the landscape, one can notice flat-topped hills known as river terraces. These terraces, typically covered with cobbles and gravel, serve as evidence of past river activity. In the foreground, gravel bars can be seen, deposited by the river in much the same way as the gravel found on terraces. By carefully studying these formations, geologists gain insights into how rivers have historically flowed and changed over thousands of years. Looking closely, another terrace can often be spotted about 20 feet below the main one, providing further evidence of river evolution. Rivers constantly reshape their landscapes. As they flow, they erode the land, carving deep valleys and meandering across plains. Over time, rivers change their courses, creating new channels and abandoning old ones. Imagine a cross-sectional view of a river cutting into the land. In this view, the river acts as a sculptor, gradually eroding the earth beneath and around it. As the river moves, it widens valleys, creating sweeping curves and loops in its path. This process continues until significant climate changes alter the dynamics of the river system. During the Ice Age, massive glacier covered large parts of North America. These glacier dramatically changed river courses, including that of the Missouri River. As glacier advanced, they blocked the northeastward flow of the Missouri River, forcing it to seek an alternate route. When the glacier began to retreat, they left behind a reshaped landscape, filled with new valleys and river terraces. As a result, the Missouri River was permanently redirected southward. By taking an imaginary field trip across the northern Great Plains, one can further understand the evidence left behind by ancient river systems. Hiking across gentle rolling hills, one may encounter a broad valley with no river currently flowing through it. By studying the length, width, and gentle curves of the valley, geologists can determine that a river once carved this landscape. But if there is no river there today, what happened to it? This is where geological investigation becomes crucial. A closer look at the Milk River, another waterway in the region, provides additional clues. The Milk River has a relatively small flow compared to the wide valley it occupies. This discrepancy suggests that a much larger river once flowed through this valley. Observing from above, one can see how the valley of the Milk River expands from a narrow quarter-mile width to 2 or 3 miles wide. This widening suggests that the ancient Missouri River once merged with the Milk River, flowing north into Canada and creating this expansive valley. However, a major geological event, likely the advance of a glacier or a massive landslide, diverted the Missouri River, causing it to shift southward into its present-day course. The discovery of ancient terraces and river channels along the Missouri River's route confirmed geologists' theories about how glacial activity influenced the river's history. During the last ice age, massive ice sheets covered much of the northern continent. As these glaciers moved, they reshaped the landscape by eroding existing river valleys and depositing vast amounts of sediment. When the glacier blocked the Missouri River's northeastward flow, the water had to find a new path. Eventually, the river was forced to turn southward, where it connected with the Mississippi River and began its journey toward the Gulf of Mexico. The evidence left behind by this transformation is still visible today. The terraces and abandoned river channels provide a window into the past, revealing how the Missouri River once flowed in an entirely different direction. These clues allow scientists to reconstruct the timeline of events that led to the river's dramatic shift in course. Other rivers in the Yellowstone region also provide insight into geological history. The Yellowstone River is unique in that it is the longest undammed river in the contiguous United States. It originates in the Absaroka Range in Wyoming, flows north through Yellowstone National Park, and continues through Montana before joining the Missouri River. The Snake River, another important waterway, begins in Yellowstone National Park and winds its way through Wyoming, Idaho, Oregon, and Washington before emptying into the Columbia River. Each of these rivers plays a crucial role in shaping the landscape and supporting diverse ecosystems. The Gallatin River, which begins in the northwestern corner of Yellowstone National Park, flows through Montana's Gallatin Valley. Known for its crystal-clear waters and rugged canyons, it is a popular destination for fly fishing, kayaking, and hiking. The Firehole River, another tributary, flows through Yellowstone's geothermal areas, absorbing heat from geysers and hot springs. The warm waters of the Firehole River create a unique environment for aquatic life, demonstrating how geological activity influences river ecosystems. One of the most remarkable rivers in the Yellowstone region is the Lamar River, which flows through the Lamar Valley in the northeastern part of the park. This valley is often called the Serengeti of North America because of its abundant wildlife. Bison, wolves, elk, and bears thrive in this region, supported by the rich habitats that the river provides. Understanding the dynamics of rivers like the Lamar helps scientists piece together the complex history of waterways across the continent. River terraces continue to offer invaluable insights into historical water flow patterns. These formations tell the story of climate change, glaciation, and the powerful forces that shape the land over time. By studying terraces, scientists can trace the ancient roots of rivers and their transformations. The Missouri River's journey, from its early days flowing northeast into Canada to its present-day course, reminds us that our planet is constantly evolving. By analyzing sediment layers, studying abandoned river channels, and observing river terraces, geologists have unraveled the mystery of the Missouri River's past. Their discoveries highlight the impact of glacial activity on river systems and reveal how massive natural forces can reshape landscapes on a grand scale. The Missouri River's dramatic change in direction stands as a testament to the dynamic and ever-changing nature of Earth's waterways. Thanks for watching. Keep it and stay tuned.